Hi everyone, welcome back. It's ALEK's walkthrough number 7 and I am your host, Robert J. McKeown. I'm very pleased that you've decided to watch this video. As I mentioned in video 6, being able to manipulate an equation is very important as an economist. And as an undergraduate student in economics, you're going to be asked to do that many times. And today's topic is about radical expressions, so that's like square roots. Square roots show up a lot. And one reason why square root functions show up so much in economics is because they display diminishing marginal returns. You're going to hear an awful lot about marginal everything's in economics. In economics, we say almost all the excitement happens at the margin. And when we say margin, you can kind of think of that as like a border. And when we have diminishing marginal returns, well, that's just like, if you have one ice cream cone, one ice cream scoop, you're going to enjoy that a lot. If you have a second one, maybe you'll enjoy that a lot too, but maybe not as much as the first one. And if you have three, well, maybe now you're going to get a stomach ache, so you're not going to enjoy that as much as the second one or as much as you enjoyed the first one. So that's sort of the idea. So square roots show up a lot in economics, and it's very important to be able to manipulate them. Fortunately, as you'll see, it's a lot like any exponent. Now, before we jump into the video and we start doing some work together, don't forget, you should have your pencil, you should have some paper, scrap paper, a notebook, what have you, and if you've got the money, invest in a tablet, because if you write it on this screen, you can save it and then you can keep it in an electronic file forever and ever. And with that, let's do some problems together. Let's start off talking about what a radical expression is. A radical expression is any mathematical expression that contains this symbol. That includes the square root, but is not exclusive to the square root. So it could also be a cube root or any root to any number that you like. A few definitions. Many roots create what we call an irrational number. And the definition of a number that's irrational is one that cannot be written as a simple fraction. So for example, the square root of 2 and pi are irrational numbers. When working with square roots, you always want to remember that it's not possible to take the square root of a negative number. The square root of a negative number is undefined. And these are sometimes known as imaginary numbers. Imaginary numbers are important if you're studying quantum mechanics, quantum physics, but they're not important, or at least I've never found them to be important in economics. It's not something we use in economics. In economics, we focus on the real numbers, which I'll show you in this next slide. We've been asked to graph a square root function. So it's the most simple one we can possibly have. It's the function which is equal to the square root of x. And this function will look something like this. Maybe I'll label it f of x. And if x were equal to 4, and I haven't drawn it to scale very well, y is going to be equal to 2. And if y is equal to 3, x must be equal to 9. Now everything in this space, these are our real numbers over here. And then anything over here, at least on the x-axis, focusing on the x-axis here, we don't know. These are undefined. For our purposes, the square root of a negative number is undefined. We don't know what it is. We don't know what it is. If you want to learn more about them, by all means, take a course on complex numbers, take an advanced mathematics course, and knock yourself out. Here's our first ALEK's question. We're asked to find the domain of what has been described or given to us is a radical expression. It's a radical expression because it has a square root. And we're supposed to write our answer using interval notation. So this is a more complicated square root function than the one we did together on the previous slide. Now, we don't need to draw anything. We don't have to graph anything. We just have to figure out for which values of x is there an answer for y. So I'll rewrite our function as y is equal to negative x, negative 8x plus 24. And the first thing we can notice here is that if x is equal to 3, y is equal to 0. Or, well, I'm getting ahead of myself. Y is equal to the square root of 0. And the square root of 0 is just equal to 0. If x is greater than 3, then y will be equal to a negative number, which means y is undefined. So we won't know what y is if x is larger, strictly greater than 3. If x is less than 3, then y is equal to the square root of a positive number. And y is defined. It's going to be equal to, y is equal to a real number. So by just sort of looking at the expression and making sure that I'm not taking the square root of a negative number, I know what the domain of this function is. And in interval notation, I might write x is in the space, well, any number less than 3 will give us a positive value for y. So I can go all the way to negative infinity. Let me try and write that again, negative infinity. And the number can be, x can be as large as 3. And I'm going to make sure I put a square bracket because x is allowed to be equal to 3 or less than 3. So here I am on ALEK's, and it's asking me to write my answer in interval notation. So I guess maybe I'll start off by picking the correct brackets that I want, and it's this one right here, where it's a rounded bracket on the left because it's an open space, and it's closed on the right. It can only go up to 3. And I'll just click this negative infinity symbol, and then I'll click into the right side box and I'll put in the number 3, and I'll click on check, and we got the right answer. Notice it didn't have to do the x is in this interval or x is in this set. We just had to put in the set itself. That's all ALEK's wanted. Let's do two things with this question. First, I'm going to show you some alternative expressions for this thing up here, this radical expression, and I'm going to then simplify it. I'll put it into as simple expression as possible. So there's a connection between these square roots, cube root expressions, and exponents. So I could rewrite this as an exponent like that. And we already learned some exponent rules, so this is good for us because it turns out square symbols, square roots, cube roots, they all follow the same exponent rules. And often in economics, we just choose to express everything in exponents because it's a little bit, maybe a little bit easier that way, but you need to be able to go back and forth between exponents and square root symbols effortlessly. And this is going to be really great practice for you to do that. So according to the exponent rules, I could rewrite this again as 250 to the power of 1/3 multiplied by x to the power of 1/3. And if I wanted to, I could rewrite this as the cube root of 250 times the cube root of x. So I'm using these exponent rules that we learned previously. Now let's simplify. So let's simplify this expression up here. There's not too much I can do with it, but I'll notice that if I have 2 times 125 times x, so I'm sort of factoring out that 250 a little bit, I can write this in a more simplified version by noting that 5 times 5 times 5, which is equal to 3, is equal to 125. And so I can take that 125 outside of the square root. So I'm going to have, I should be careful with my writing. I've got the cube root of 125 times the cube root of 2x. And this thing on the outside is just going to be equal to 5. And I've got 5 times the cube root of 2x. And that's as simple as I can make this expression. Okay, let's tackle a more challenging problem. You can read the expression in front of you. You can see it on the slides in the video. How are we going to go about simplifying this thing? Well, there's a few different ways to go about it, I suppose, and I've been sort of sitting on the fence how I'm going to show it, but let's do it this way. So let's notice that the square root of 24 can be written as the square root of 4 times 6. That would be one way to do it. Or maybe, yeah, okay, I guess that's fine. But we could go further. We could say, well, this is also equal to the square root of 2 times 2, that's 4, times 2 times 3. 2 times 3 is 6. So I've now written it in its lowest possible factors. Similarly, I can look at the square root of 98. Now, while the square root of 98 has no particular significance for me, I know that anything that's a even number divided by 2 is going to produce a whole number. So if I rewrite this as 2 times 49, I'm a little bit closer to something useful, because then when I see 49 and I know my multiplication table, I know that 7 times 7 is equal to 49. So I'm going to go a little bit further here. I've got 2 times 7 times 7. And so why don't I bring this all together, and I'll write, I've got the square root of 2 times 2 times 2 times 3 multiplied by 3 and multiplied by 2. Oh, I should be careful here. Square root of 2 7 and 7. Now, I can do a few things. So I notice that maybe I want to look at the fact I've got 4 2's. I've got the square root of 2 4 times. So I'll rewrite this as the square root of 2 to the power of 4. And I've got 2 3's, and I'll rewrite that. Oh, no, excuse me. I've got a square root of 3, and I've got a 3 itself. So I'll just put the 3 there. I'll put the square root of 3 there. And I've got 2 7's. And so I've got the square root of 7 squared. Now, you should see that if I've got the square root and I've got the square, they're going to cancel each other out. So I've got 2 squared to the power of 4. That's going to give me 4. And I've got the 3 that's still sitting there. And I've got the 7. And I've got the square root of 3. And now I'm going to have 12 times 7 times the square root of 3. 12 times 7. Oh, my multiplication table up with the 12s is a little shaky, but I know that 7 times 3 is 21, and I know that 4 21s is equal to 84. So notice that I'm doing this. I'm trying to do this without using a calculator. If you used it with a calculator, there wouldn't be much of a challenge to it. But it's handy. Now we've got our answer. Let's put our answer into ALEK's. So I'll start by typing 84, and then I'll click this button right here. And so the first little box represents the 84, and then I've got the square root symbol that's going to be put in for me. And I type in 3, and if I hit the check button, we've got the right answer.